before, and here we're dealing with a topic called lean production. I suppose I should have put actually lean production up here. Now, lean production is a pretty massive topic. What happened in the 1970s and 1980s? Japan decided to operate lean production, and their economy became incredibly successful. In fact, at one stage they thought Japan was going to become eventually wealthier than America, which sounds strange now because what's happened is China's taken off. So by the year 2025, China will be the biggest sort of economic empire in the world today. But in the 1970s and 80s, it was Japan. Now, what happened was there's a guy called Peter Drucker who came up with this new idea about how to run manufacturing plants, and the Japanese adopted his particular systems, and that system was called lean production. And lean production is the main production system that manufacturers use in the world today. So I'm going to explain that whole process to you and how it works. Although previously I've just been looking at the 10 megatrends, 3D technology, nanotechnology, and all of those things. So this may start to throw all of this in a slightly different direction, because for instance if you use 3D printing, of course you don't necessarily need to have loads of suppliers producing all the little parts for you, because you can produce them all at your own factory. So automation, technology, these are going to be the big issues moving forward. And I keep on going on about that's going to lead to massive rise in productivity. I call it the third industrial age and everything else. Okay. But right now we're looking at lean production. Lean production is, if you adopt it, then you're going to have an increase in efficiency, you're going to have an increase in the productivity, and in many ways you are going to be using your capacity much more efficiently, because you're only going to produce what is actually needed. So there aren't going to be, in theory, there won't be any stock holding costs or storage costs or cars getting out of date. So you've got that on there. And if you can keep in the background of your head all of these 10 megatrends that are occurring in manufacturing. Now, what does lean production mean? Lean production means no waste, right? So we don't waste anything at all. And it's basically run on a just-in-time system. So what happens is you only order what you actually need. You have your suppliers very close to the firm, so you phone them in the morning, you say, or via IT systems, you get hold of them and say, right, today we're going to need this and this. And these small manufacturers are incredibly efficient and productive at producing set parts. So it's very important that your firm has a very good supplier base around them, because if the suppliers do not do their job, then the whole just-in-time system breaks down. Because we're going on to the system again here of no waste. So focus on holding the minimum levels of stock. Materials are delivered just before they are required. Okay, so it's just in time. The next process here is Kaizen, and Kaizen is an approach that systematically leads to an improvement in productivity. And what happens is all of the workers will get together and they will decide on how they can improve their particular area, and then that information is put up towards their management. Right, so it systematically improves the efficiency of a business, but maybe Kaizen works really well in Japan because people are used to working in teams, are used to discussing things and everything else. But we also have it within the UK, because we're a really good producer of cars, even though the companies are owned by other people. So what happens here is we have productivity going up this axis here, productivity, and here we have time. And you have these Kaizen groups, they get together after work and they decide on how they can improve their performance. And so through time, productivity constantly goes up. So we're also treating the workers as theory Y workers. Okay, we also have a thing called time-based management, which is getting our output to the market as quickly as possible. And it aims to reduce the time needed to develop new products. So it's much shorter lead times. Now, I've just drawn up a make-believe critical path analysis here. I'm into building cob houses, which are mud houses, and I produce very small ones, probably about the size of this room here. And we start off on stage one on 0 days. So we start at 0, and we can do a thing called simultaneous engineering. We can do 3 things at once. I can put the foundations in, I can do the gardening around the little house at the same time, and I can also dig a nice vegetable plot. Now let's assume they all take 7 days. I can do all of these things at once. So I can get someone doing the foundation, someone doing the gardening, and someone making the really nice vegetable plots. We all get to know too, it's only taken us 7 days to get there. Okay, so I put a 7 in there. Don't worry about this time at this moment in time. Right, the next stage is I need to put the roof on. I need to put the roof on, and when I put the roof on, I also need to put the wood burner in, obviously, because there's going to be a hole in the roof where the wood burner will come out, and I need to order furniture, which will then go into the cob house. Okay, so to do all of this will take me up to 14 days. Okay, so 7 plus 7 is 14. If I happen to take, let's say, 10 days to stick the wood burner in, then the earliest start time I could get there would obviously be 10 plus 7, which will be 17. Okay, but it doesn't. I've just assumed that it's going to take 7 days. So 7 plus 7 is equal to 14. So you're actually going to think now I'm obsessed with 7. Right, but let's say it takes me 7 days to put the flooring in and to put the paint in, and maybe I've ordered the furniture now and I've got to make it all look nice and pretty, so let's get the furniture on here, and it also takes me 7 days to do that. 7 days to do that, so I can finish the whole project within 21 days. Now what does that mean? In 21 days I can get someone in to the cob house, paying rent, and hence I'm getting my money back pretty quickly. So this is shortening the lead time. So to get this whole process to market, at the same time, what I could also do, other activities at the same time. I could market this whole process, Twitter, social media, produce a YouTube video of this house being built. We can build a little car park to stick the car in. That's going to take 10 days. But none of these activities are critical, so I can still finish the whole project in 21 days. Now, if any of these things are delayed, or if any of these things take longer, then the whole project will be delayed from there. So this gives us this figure on here, 21 days, and I put 21, 21. It'll always be the same. This figure here will always be the same as this one. And then I do 21 minus 7 is 14, and 14 minus 7 here, and we go all the way back. Now, on this one is a slightly strange one, I suppose, because the critical activities, if any of these projects here are delayed, then the whole project will be delayed. Right. But I'm just going to give you a very simple example of how this works. So I've got this situation on here. We do this much later on in the course, and we've got 25. So it's going to take us 25 days now to do the marketing. Okay. So the earliest time I can get there is 25. Everything now is overridden. This now becomes the critical activity. Right. If I can reduce that time, then the whole project will get to market more quickly. But as I've got 25 in there, I've got 25 in here, and then I go 25 minus 7, that is 18. So these activities are now not critical, okay? Because I can be delayed. I can be delayed by 4 days, and I do 18 times 7 again. Sorry, then I do 14 times 7. Sorry, I do the latest finish. I do 18 minus 7, and that gets me to 11. So now what we have is this thing called float time. So the critical path is this one here, and here we have float time. These activities are non-critical. Of course, in reality, what may happen is, right, we may say it takes us 17 days to put everything in. Now, if that happens, right, let's just completely change this model around. This then becomes 17. 7 plus 7, this then becomes 24, and 24 plus 7, this one becomes 31, and the earliest time there becomes 31. Now in this case, this activity is no longer critical, okay? So we're no longer on the critical path. Clearly, the critical path is now this one, okay? In fact, it's all three of these, because if any of these projects here are delayed, then the whole project will be delayed, and it's all three of those as well. As I say, it's a slightly unusual critical path analysis. And then we go back from here, we do 31 minus 7, and that is 24, and then we do 24 minus 7, that is 17, and 17 minus 17 is equal to 0. So on here, this is a critical path analysis, and it's all about saving time. And the quicker you can get your product to market, the quicker you can build your house, the quicker you can rent it out, or in this case it's a cob house, the quicker you can get your cob house, the quicker you 2034, and if you can remember that lean production means no waste. And what I did in the previous session, I just had a very quick look at just in time, trying to reduce time-based management, trying to reduce lead times, and Kaizen. That's the workers when they all meet up and they all discuss how they can see problems within the firm and change them around and everything. So this is also part of lean production, means no waste, and it was adopted in the 1970s and 1980s by Japan. It became the great economic powerhouse in the world, and we thought Japan would take over America. But it also revolves around this idea of cell production. And what I'm here talking about is all these workers here. Now, they all get together at the end of the day and they have a thing called quality circles, which is also Kaizen, where they all get up and they all meet and they decide how they can improve their system. They are given complete responsibility for that cell. Now, this is very much against the old system, whereas before they have the leader at the top, and the leader at the top will make all of the decisions, and then these workers would just act like a bunch of monkeys and produce the products. This is no longer the case. So it is very much theory Y based. Theory Y, you've written it twice. It also works on a pull system, so you only produce what is needed. So really within the factory is you have all these groups of people on here, and they're all in charge of a cell, and they all make sure that that particular process is actually very, very good. They then communicate their ideas to the management. Because they're on the ground floor, they know what is in fact going on. So this is cell production. So this is also part of lean production. It is benefits of using technology, but it's also about capital or labour. Now, the benefits are pretty obvious: reducing costs, you can improve quality, reducing waste, you can increase productivity, and there's easy communication. Machines don't break down, people do. People are actually pretty expensive to employ because you've got to pay national insurance contributions, you've got to give them a car parking space, and all those factors. Right. The drawbacks of using technology, obviously, initially it's going to cost you enormous sums of money, and employees will need to be trained. That there's going to be very high maintenance costs, and it can also break down and halt production. Now, one of the things that I quite like about cobbing is that you're going back to the old days and you're using old materials. You're just using soil, right, or clay soil to make these houses. So in a way, we've gone back to the past. But in a way, I also see it, because it's got the solar panels on top and everything else, and it generates its own electricity. I see it as a highly modern house, but it's sort of an old-fashioned house as well. Now, within an essay, or to have in the back of your mind, you're going to have to analyse all of this. So what you're going to say is, this is really good, this is going to increase productivity, this is going to reduce your costs, so therefore your profits are going to go up. However, it's going to take a big hit in terms of your cash flow. And if you make the wrong decisions, then you're going to be totally overtaken by other countries in the world today. So you can actually go bust if you spend loads of money on your technology, but you're going to have to look at the situation that you're in at that particular time. The initial costs will be very high, the employees will need to be trained, there's very high maintenance costs, and it can break down and halt all of your production. But hopefully, in the long term, short-term cash, in the long term, you will increase your profits from there. The analysis of this in the world today, these companies, Toyota, Nissan, in fact, all car manufacturers, they spend an enormous amount of money on technology. In fact, an interesting one is Volkswagen's Skoda, because Skoda produces the cars cheaply in Eastern Europe, but a lot of their technology is sort of technology that's already been used on Volkswagen. So the Volkswagen is at the cutting edge of technology, and then the Skoda is just a cheaper version of that. And that has saved costs in terms of they're using their technology even more effectively, but it also creates a lot of revenue for the firm. But anyway, obviously those firms today that have embraced technology tend to be those firms that have done really, really well. Now, but then this relates really to one of the other topics I'm interested in, which is manufacturing, partly because we're doing a research assignment for the year 2014, and I've got 9 of the megatrends here, because one of them isn't to do with capital. We've got 3D printing, so maybe suppliers aren't so important. Hopefully we've got resource efficiency down here. There's a lack of resources in the world today, so we don't want to use waste. New ways of producing goods, nanotechnology. We've got to have a talent challenge, because you need the workers to run these more sophisticated machines. There's going to be cluster manufacturing, where you're going to get all the machines, all the manufacturing machines in one place. And we've got to keep in our heads that what is the factory of the future in fact going to look like. So, but I suspect, once again, this is going to be the third industrial revolution from here. Okay, so this is capital or labour, and I've got one more session on this for lesson 34. Okay, we're on lesson 34 here, and I just wanted to bring this particular one here, which is economies and diseconomies of scale. Now, economies of scale, on here we're going to have the average total cost curve. Economies of scale is really the bigger the firm, its output increases, your costs per unit will fall. And that is called economies of scale. And I put down here 4 economies of scale, which is you get financial economies, it's easier to raise money. Trading economies, because you're dealing with a larger number of products, so therefore it's cheaper to export those goods. Managerial, managers can specialise in what they are best at, and also obviously technological, which is probably the most important one, is you can really utilise very expensive machinery, so therefore your cost per unit will fall. Now it's called economies of scale. But we also have diseconomies of scale, and that if a firm becomes too big, then communication becomes more difficult, coordination becomes much more trickier, and also motivation. The workers may not be motivated to work there because the firm is so large. Now, particularly when we're talking about the 10 megatrends in terms of manufacturing, one of the difficulties is firms get bigger and bigger and bigger, and you've got your suppliers out in Japan and your suppliers out in Vietnam or whatever. So therefore, obviously, communication and coordination of those activities and the motivational levels of those workers at those particular places becomes much more complex. Now, therefore, when you're using technology, right, so this is one of the big mega trends, or when we're using 3D printing, no longer does the firm need to be massive in terms of the numbers of people. So that level of communication, coordination and motivation isn't as big a problem. Okay, so economies and diseconomies of scale, and what you want to do is you want your firm to be able to achieve economies of scale, but if you can achieve economies of scale, then your costs per unit will fall. But it's not always. A really good example of this actually is Ryanair and Aldi, who have simplified their operations, so they followed a cost minimisation strategy. And in fact, what Ryanair went out and did was they landed at the smaller airport, so it was much cheaper, but they also used a lot of second-hand aircraft initially, so therefore their cost base was far lower than anyone else's. Aldi and Lidl have done the same things. They haven't gone for huge shops. Right, they've gone for much smaller shops, so their cost per unit will actually fall. And whereas the Tesco's has 22,000 lines, Aldi has 1,200 lines. So the shop is therefore much smaller and much simpler. So they've simplified that whole process down. In my view, building a cob house is cheaper than buying in a mobile home. A mobile home may cost me £14,000-15,000 to build a cob house, will cost me whatever, but it's much less than that. So therefore you are beating the competition because you've got a cob house and they've got a mobile home. So it's not always just about technology, but in terms of the big things like cars and iPhones, maybe technology is obviously very, very important there. But one of the key things examiners want to see is the fact that you can use economies of scale, and if you can use economies of scale, that means your cost per unit will fall. But you also have diseconomies of scale, and it's really just one sentence you use in an exam. It says, well, this firm may be suffering from diseconomies of scale, which is coordination, communication, and motivation. For example, the supplier there's a lack of motivation with the suppliers in to Vietnam, with the suppliers in Vietnam. So. And they're producing the goods not to the required standard that's expected for the British market. Okay, so this is this subject here, and we're dealing with lean production, but it's all about increasing efficiency. The problems of lean production. The biggest problem of lean production quite clearly is suppliers. You need to get your suppliers on tap, and using optimal mix of resources. Should we be using technology or more labour? And there seems to be a trend, obviously, these days towards using more and more technology. Okay, thank you.